In this video, I'm going to be going through a Copeland question. I'm just trying to find out what the exercise number is. It's on page, example 1.4 on page 20. Example 1.4 on page 20. Example 1.4, page 20. I've probably gone through this on other videos, but I'm going to go through it in one big video now. I'm not going to do all three, I'm going to do two, and I'm going to leave you to solve one of them. So the first thing is, ordinarily in the HSC, they would not give you these reactions. They would give you the load conditions, and it would be up to you to determine the reactions. Luckily for you, though, to help you, if reactions are what you're struggling with, if that's the part you don't understand yet, well, we're going to help you out. So we're going to say that they're giving you the 270 and 180. They don't want this to be the part of the question that you get wrong. Okay, so the next thing to do is we are going to use method of sections. We're always using method of sections. Only me and Snoop Dogg use method of joints, right? When we use method of sections, we've got to decide, first of all, the first step is we have to figure out where the section is going to be. We could cut like this, we could cut like this, we could cut all different locations. Now I will tell you that there's usually 1 mark in the HSC just for showing the cut. Right? If you draw the section on your diagram already, the markers are going to look to give you 1 mark, especially in a big question like they have been in the last couple of years. They've been 6-mark questions. Now, once you've found your cut, we're going to cut through here. Now, we're going to cut through here because we want to find 1, 2, 3 targets. Normally we have 1 target, but when we cut, we want to have our target, we want to cut through our target and no more than 2 distractors. If we have more than 2 distractors, two other members that have been cut, we're going to have a problem. Now, I've cut through that, and I've redrawn it here in blue. I've just said we're just looking at the left-hand side. We could do the right-hand side. Sometimes for homework, I make kids do the right-hand side for homework. Now, I like to think of it as, imagine in Despicable Me, the Gru and Vector have set a competition that they're going to steal half of a bridge. Right? That's the trick, is they have to steal half of the bridge, but the bridge has to stay standing. So Gru has got this plan where he's going to use drones, and then he's going to connect them, but he needs to know exactly how strong each of the drones needs to be in order to provide the force to maintain the load condition that was already there. Right? That's what we're looking at here. We're trying to find out what is the force that's acting inside this member, right? The internal forces. We've just picked 3, but normally you would, if you're doing a design, you would find all of them. And in the HSC, they will just ask you to find 1, typically, maybe 2, right? Usually 1 or 2. Now, we've put our cuts. We know we're using method of sections. This is our section. There are 2 different techniques we can use within method of sections. 2 different we need to use, depending on the circumstance. Right? There's meetup and lone wolf. Meetup and lone wolf. We'll see why that's for example. Now, I've named these 3, BG, FG, and EF. Right, so what we want to find is, first we're going to find BG, right? We're going to find BG first. When we find BG, we have 2 distractors. We have our target and 2 distractors we need to eliminate. What do? We find our location where these 2 meet up. Because if we can find where our 2 distractors meet up, we can eliminate them from the equation. I'm going to call this L. Right? Normally I'd call it X, to be honest. That's normally what I would call it. If it's not labelled, I'd call it X. But in this case, right, that's why I've written a question mark, but normally I'd call it X. In this case, where do FG and EF meet? We're going to call that location F, because they both pass through the point F. Now, what that means is, when we type in our equation, these multiply by 0. Why do they multiply by 0? Because moments equals force times perpendicular distance. Right? If the perpendicular distance is 0, it doesn't matter if this is 1 trillion, 200 billion, right? It doesn't matter. It doesn't matter because it multiplies by 0, so we can ignore it. Right? That's why, now, how many forces are there on this diagram? Counting from F, we have EF, that's 1, 2, 3, 4, 5. Right? I knew there was 5, and that's why I remember. Okay, 5. There are 5 forces. Let's have a 1, 2, 3, 4, 5. Often, Copeland and others, they won't include these 2. They just won't even write them, because they're 0. They multiply by 0. I think it's important to know that they were there, and that's the reason we use moments, is to eliminate those 2 unknowns. Okay, now the next thing we need to do is we need to know the distances. I'm not going to teach you geometry in this video, right? If you need to figure out the geometry of this, that's a separate lesson. But what I will say is this diagram, we can assume, if it doesn't say otherwise, we can assume that they're equilateral triangles, right? The drawings are usually drawn to scale, so in this case, they're equilateral triangles. Now I've used the polynomial t to stand for one triangle. Normally I wouldn't even do that. I would just say 1. And we'll see why in a second, because what's going to happen is, whatever distance we use here, as long as we're consistent, it doesn't even matter if we use inches, miles, cubits, hands in honour of Melbourne Cup Day, right? It doesn't matter what measurement we use, it's going to divide out anyway, right? It's going to cancel out anyway. So we're just going to call t's, right? But I wouldn't even use t's, I just use 1s normally, right? But this time around, just for the sake of it, we're going to see t's. Now, how many t's away? This is the hard part for a lot of students, is figuring out these perpendicular distances. This line, 270, it goes forever, right? It extends infinitely north and south, right? It goes forever. But its closest distance, where it's perpendicular, and this is where I used to have set squares for this, or a piece of paper, but a piece of paper will do, right? If we set this line, it goes forever. Where is it perpendicular? There. At that point, it is perpendicular to F. I wish I had something that was a little bit stronger, but I use this book. Okay, this line goes forever, and at that point, ding, it's perpendicular. That is the distance we're measuring. Yeah, the perpendicular distance. We're going to do that a couple more times, so don't worry. Okay, that we've said is one triangle away. 270 is one triangle away from F. How far away is 300 from F? Well, again, it's a line that goes forever. Let's set the perpendicular distance. At that location there, it is perpendicular. Right? At that location there, it's perpendicular. The perpendicular distance is 1/2 of a triangle. I couldn't really write that very clearly. I'm going to write it just again in black. 1/2 of a triangle. Yeah? Just so it's clear for the camera. 1/2 of a triangle. Now this distance here, for an equilateral triangle, the distance from the tip to the base, I'm just going to tell you, is 0.866t, right? Which is the same as?
Root 3 on 2.
Root 3 on 2, right? So for those people who know their maths, right, that's a trig identity, right?
60.
Yeah, sine 60. Yeah, that's another, or I should write that as well. Yeah, sine 60, thank you. Yeah. I'm not going to go into the geography of that. I just remember this number. I call it the Disco number. Okay, so, because my mate Disco was born in 86, that's how I remember it. Now, like I said, there's 5 forces, 2 of them we can ignore. Ignore. This one here, 270, I've written plus. Normally I would write negative and then I would figure it out. So, ready? I put my finger on F and I decide, is this going clockwise or anti-clockwise? I push in the direction, I push my clock arm, right? I push my clock arm in the direction of this arrow. Right? When I push up on the clock arm, it's going to go da 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 da. It's like a Wheel of Fortune. Da, 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 da. That was going clockwise. We said, and I will always say clockwise is positive. Some people in the HSC, you will see the answers are clockwise negative. Right? So, but don't worry. Okay, I just like to be consistent, right? So that my notes will always be the same. This one here. So I've got my clock arm, and I'm pushing in the direction of this arrow. Even though it doesn't touch the arrow, I just extend the line down, and I'm pushing the clock arm. What way is my clock going? It's going da 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 da. It's going anti-clockwise, so it's negative, right? Now lastly we have BG. Now with BG, I don't know which way that's going. So I've just written some red arrows there. The convention, everybody does this is not just me. Everybody assumes tension, right? Everyone assumes you just draw the arrow pulling out from the node. So see how the arrow is pulling out? If you pull out, we assume tension, right? Yeah, we assume pulling out, we assume tension. Now, if it doesn't, if the answer turns out to be negative, which is what happens, we then know our assumption was wrong, and it was actually compression, right? So even though we actually know, because we've seen the answers, that BG is in compression, we're going to assume tension for this moment. Okay, if it's tension, then let's spin the wheel. Which way? Clockwise, thank you. Clockwise is positive. Okay, now this note here, I said assume tension, therefore clockwise. You don't need to write that. I write that, and I waste precious seconds writing that because I want you to know why it was positive or negative. That is one of the things that trick people. So let's go through the things that people mess up. First of all, they don't know where to put the lines. Second, they don't know to use the meetup or the lone wolf. If they are using the meetup method, they don't know where to find the location. In our case, where these two meet up is at F, and then the next thing that people get wrong is they don't know how to use the signs correctly. So we always assume tension, and if it's tension, that doesn't mean it's going to be positive or negative. What it means is tension. Once we have the arrow, we can then decide if it's clockwise or anti-clockwise, right? Tension allows us to figure out if it's clockwise or anti-clockwise, and we always say clockwise is positive. Now, we then do some algebra, right? And we find that the t's cross out. Remember I said the t's don't matter? Yeah? So the t's cross out, and what we get is minus 120 equals 0.866 bg. Yep. I'm not going to go through the algebra. I'm going to assume that you can type in the algebra. Now, if we say that bg equals minus 120 divided by 0.866, what we get is negative. Our answer is going to be negative. Therefore, our assumption was no good. Ng. If it's good, we write OK. If it's no good, we write Ng. That's a convention in engineering, right? That's a thing that professional engineers do. If our assumption was no good, what did we assume? We assumed tension. So if it's negative, that means our assumption was no good, which means it was
Compression.
exactly right. Okay, so that gives us our answer. Now, if we're finding EF, these are our two distractors, FG and BG. Where do FG and BG meet up?
G.
G. Now, the answer is not always so conveniently in the names. Sometimes the location where they meet up could be a long way away, right? And the letters won't help you. But often, if they share a letter, you can bet that they're going to meet up at that location, right? So in this case, they meet up at point G. Now, I'm not going to go through that. The textbook has the answers for that. It's the same process. The only difference is you take your measurements from G, and sometimes these things are going to be clockwise or anti-clockwise, right? So this one here, EF will be, measuring from G, EF will be positive or negative? Negative, right? It's going to be anti-clockwise. Okay, now, we've now learnt, in a few minutes, we've learnt the meetup method. We're now going to learn the lone wolf method. Right, I didn't have a good name for this. Students came up with a great name, right? Now, in this case, we're going to take the sum of the moments in the x or y direction, right? That's going to be really apparent in a second. But the idea is it's either in the x direction or in the y direction. Doesn't matter, but as long as you can identify the sum of the moments in one of two perpendicular directions, you're fine. Now, I have a little diagram here. So in this example here, my target is diagonal, and these two here are parallel. They're both horizontal. Let's have a look. Okay, we're trying to find FG. All right, FG, it is diagonal. BG and FE, they're both horizontal. So let's have a look. If we say that in this diagram, we have two vertical forces. We have 300 down and 270 up. Right? Do those numbers cancel each other out? They do not. If they do not, that means it's not in equilibrium. That means there needs to be some other force that needs to keep this suspended half bridge in equilibrium, right? Which of the three drones is going to be the one that's going to push this thing up to keep it maintain the equilibrium?
FG.
Has to be, right? BG, it's like, nah mate, sorry, I don't do vertical forces, right? EF's like, yeah, sorry, I don't do vertical forces either. So FG is like, okay, I'm going to have to be the hero, the lone wolf who steps up and rises to the challenge and says, I will take on this vertical component, right? Now, you got to remember, the diagonal is going to be bigger than the vertical component, right? The vertical component is only part of the equation, right? In addition to taking the vertical, the lone wolf also has to take some horizontal as well. But once we know the vertical component, we can then use trigonometry to then calculate the remainder. Let's have a look. Okay, so we've said sum of the forces vertically equals 0, right? If it's not, it won't be in equilibrium. That's essential. Now, I like to draw little diagrams. I find a little diagram, doesn't need to be to scale. This little diagram is 10 times easier for me than writing out the numbers. But I'm going to write out the numbers anyway. 0 equals 270. Is it plus or minus 270? Is it positive or negative?
Positive.
Why is it positive?
It's upwards.
Exactly right, and we set a convention of upwards as positive. Not everyone does that. Some engineers like to set negative down as positive, right? Okay, then we have minus 300, right? Because it's going down. Yep, minus 300. Then we have B, the vertical component of BG. What did we say? Did BG won't take vertical component. Just doesn't do it. I'm sorry, I'm a horizontal only person, right? I don't deal with that. I'm horizontal only. FE, same deal. right? Fe only wants to go horizontally as well, right? So their vertical components are both 0. Yep. So that means, now why have I written minus FGV? Because my assumption, we always assume tension. Pulling out is in tension, right? That's what we always assume. So if it's put in tension, if FG is in tension, if it's pulling out, which way does it pull out? Does it pull up or down?
Down.
Down. So if it's down, we said down is negative. Yep, okay. So what we get is 270 minus 300 is minus 30, right? Minus 30 minus FG is going to give us an answer of FG equals minus 30, yep? That answer is negative, therefore our assumption was no good, therefore it's not in tension, it's in the opposite of tension, which is? Compression, exactly right. So that means FGV equals 30 down. Now, FGV is only part of FG. FG is more, FG's like, I'm more than just vertical component, guys. You think I'm worried about the vertical component? I am, because no one else is doing it, but I still have to take some horizontal, right? So what we're going to use there is we're going to use some trigonometry, and we're going to say if this is 30, well this is FG, if FGV equals 30, then FG total is going to equal 30 divided by sine 60. Why sine 60? Because this angle is 60 and we're using the opposite in the hypotenuse. Again, trigonometry, if that's where we need to work on, trigonometry work on that separately. Right? But if you think like I don't understand that, the thing you need to tell me is, sir, I don't understand trigonometry, or you tell your teacher you don't understand trigonometry. 30 divided by sine 60 is, I just memorized sine 60, right? So I know sine 60 is, what do I call this number? The disco number. 30 divided by 0.66 equals 34.64. Remember, it's in compression. Up here, we drew the arrow as down. That was our assumption. In actual fact, now that we know the truth, we know that it's going up. If it's going up, it's going into the node. If it's going into the node, it's not in tension. If it's going into the node, it's not in tension, it's in compression. Okay? That is how you solve trusses. Right? That's it. That video is the entirety of trusses. From that one video, if you understand this, you can do 5 marks, 5% of the entire HSC. Right? Trusses, they are very, very likely to be in the HSC. 90% chance of them being in the HSC. Right? They will absolutely be in the half yearly and in the trial. I write those things, so they will absolutely be in there. Right? So I'm telling you, learn this. Right? We covered it in one video.
Done.